Hello everybody. At this point in our class, we're about to learn about something called a logarithm, and logarithms are closely related to exponents, so that'd be good and it might help some people if we had a quick review video about exponents. Quick disclaimer, if you have no clue what an exponent is, this video might be a little too fast for you, but if you just need to get it fresh on your mind and maybe learn about a few new things, then I think the video might help you. Okay, so exponents can be positive, negative, or they can be a fraction, and I just want to talk about the differences between all of those and give you some examples, and like I said, just have it fresh on your mind in case you see this type of thing in the next unit. Okay, so a positive exponent just refers to repeated multiplication. So if I have what you see here, 4 to the third power, that means to take the 4 and multiply by itself 3 times. 4 times 4 times 4. If you take 4 times 4, that's 16, and if you take 16 times 4, that's 64. So if you just multiply these together one at a time, once you got it written down, you get 64. Some vocabulary that you might encounter along the way is that when we have 4 to the third power, 4, the number that gets multiplied repeatedly, is called the base, and 3, the power, is also called the exponent. Okay, now, of course, you can do this with a handheld calculator. I'm not denying that, or an online calculator. It's a little hard for me to show you with this, in my hand, how you would do this, but if you have a scientific or a graphing calculator, the interface might look something like this, and if I wanted to use the exponent feature, I type in the base, and it may look like this. Okay, I didn't really want to make a video about calculators because the way the keys are labeled can vary a little bit. The interface can look a little different, and I'll just say if you're having problems using a calculator of any kind, then you can let me know and I can help you individually. So if I want to do 4 to the third power on a calculator, then here is the exponent key, at least on this interface. Okay, and it would look like that, and it tells me 64. All right, now, yes, I know that you can do this on a calculator, but that's not what I want this video to be about. Okay, as it is that our class is a college class and it's somewhat academic, part of my goal is to have you know as much as you can. All right, so yes, calculators make things easy for us, and it's not like I don't want you to use a calculator, but I also want you to know how to do things on your own. Okay, just because I want you to know everything that's involved in this. I don't want you to be completely dependent on a calculator, even though you might use one most of the time. Okay, so the whole thought on the class is that it's just good to know things, and I want you to learn as much as you can. All right, so let's look at another example. So say we take -2 to the fourth power. So when I write it like this with parentheses, the base is the number -2, and the exponent's 4. So I multiply this -2 by itself 4 times. So it's going to look like -2 times -2 times -2 times -2. And if we break this down a little bit further, like, well, what's -2 times -2? Well, negative times a negative is a positive, and 2 times 2 is 4. All right, and same thing with this one. That is also 4. So this looks like 4 times 4, and I get positive 16. So yeah, I could take a negative number and have an exponent. And it turns out if that exponent is an even number, a negative number raised to an even power will be positive. A negative raised to an odd power will be negative. But if you just break it down, multiply, you could get the answer that way. It's not like you have to memorize how negative numbers work. Okay? All right. So that's how we think about positive exponents. It's just repeated multiplication. Sometimes we will have negative exponents, so let's talk about that a little bit. Say that, let's just use a rule for this one. If I have some number a to a power -n, or I'm trying to tell you that power is negative, then that is 1 over a to the power n. So the negative exponent is corrected this way. Okay. And you could just think of that as a to the power negative n if you want to. If I say that what it looks like happens is that this moves on the other side of the bar, okay, then by that I mean that we have like there's always a fraction, like every number is a fraction. If it's not explicitly written as a fraction, you put a 1 under it, okay? So what is above the bar with a negative exponent, below the bar has a positive exponent. You think of it that way if you want to. Okay, this one on the other hand, say we have a negative exponent under the bar. Well, then 1 over a to some power negative n, where that negative n is meant to be a negative exponent, is a to the power n. So maybe you can step back and look at this, that there's two positions that any number can be in. Okay, it can be above or below the fraction bar. And negative exponents are corrected by just crossing the bar from either up here to down there or down there to up there. Okay, so let's look at some examples. So what if I had 5 to the negative 3 power? So that would be, according to this, 1 over 5 to the third power. But 5 to the third power, because of exponents when they're positive, referring to repeated multiplication, is 5 times 5 times 5. 5 to the third power, that's 125. It's 1 over 125. What about this one? 1 over 2 to the negative 5 power. Well, I mean, according to this, like if that number has a negative exponent under the bar, then I can move it above the bar and it will be positive. So 1 over 2 to the minus 5 power is 2 to the 5th power. And again, that means take the 2 and multiply it by itself 5 times, so you're looking at 2 times 2 times 2 times 2 times 2. And if I just did this one number at a time, I would work my way up to 32. That's what I'm saying. I know I've already mentioned it, but of course you can do this on a calculator. I know that, and you know that, but what did I say earlier? I said that I wanted you to know how to do it on your own. It's fine to use a calculator, but I don't want you to be completely 100% dependent on one either, just because I want you to know and learn everything that you can. All right, what about this one? 4 times x to the minus 3 power. So as it is, we're in algebra. Algebra is, I guess you could say, how we do math with symbols other than numbers, okay? Like, 5 and 3 are numbers. This is just a matter of calculation. This is not algebra. But when we have an x or a y or a z or some symbol that stands or represents a number, then we're doing algebra. So this x, I don't know what number it is, but I'm supposed to handle it in whichever way would be appropriate. Before I do this one, I included this one in my notes because I'm afraid most people might think that, okay, they might reason this way. They might say, well, we have a negative exponent, and according to this, we'll just move it under the bar, so this will be 1 over 4x to the third. Okay, so that's what I'm afraid most people would think. But I'll point out to you that the x has the exponent of negative 3. The 4 doesn't, okay? It's not like it's this. If it was this way, if I had a parentheses to group that together and then put the exponent, well, then the entire number 4x would have the exponent of negative 3, but that's not what we have. The 4 does not have the negative power. It doesn't apply to it. It has nothing to do with it. So this would not be the right way to think about it. You have a 4, just a 4, and then you have times an x with a negative power. So let's take it apart a little bit. I have 4, okay, I'll write 4 over 1. Since I'm going to end up dealing with fractions. I want everything to match up. 4 is not a fraction, is it? Well, I can put a 1 under it, and it is. Times x to the minus 3 power, but that, as it has a negative exponent, is 1 over x to the third power. So if I take it apart a little bit, I'm looking at it like this, okay? But then I could say, well, I have fractions that I'm multiplying, and the way that you multiply fractions is straight across. So this is 4 times 1 over 1 times x to the third power. So you get 4 over x to the third power. All right, so it's fine if you go straight there. You don't have to have an elaborate thought process like I gave you, but I just in case it would help you to see this taken apart into its pieces and put back together, that's how we think about it and get to here. All right, but either way, I just want you to see how we can get from here properly to over here. Okay, let's talk about fractional or rational exponents. Okay, so here I want to give you another rule that you apply, and I'll describe it this way. Say you have some number n to a power a over b. Then that can be thought of as the b root of n raised to the a power, like this or like this. See, I put an or and I have two things that look slightly different. Okay, in either case I see that b is the root and a is the power on the number n. But what is the difference between those? Because either of these would be appropriate and correct. In this first one, the order of operations is take the b root of the number n, and then when you're done with that, raise it to the a power. And then this one has the opposite order of operations. It says take the number n, raise it to the a power, get whatever you get, and then take the b root of that number. So the only difference here is the order of operations, but you know what? You'll get the same answer with either order of operations. So you can use either one of these, write either one of them down, and you might see either one of them as you go through the assignments. Okay, so let's do some problems with this rule and pattern. What if I had 4 to the 1/2 power? Well, based on that pattern I just showed you, that would be the second or square root of 4 raised to the first power. Okay, that's consistent with writing it like this. So that would be, I suppose, just the square root of 4, and the square root of 4 is 2. So 4 to the 1/2 power is 2. Okay, and you could say as a general rule that since we see it so much, n to the 1/2 power means the square root of the number n. Okay, work it out according to this pattern, but if it turns out you just happen to remember it this way, that's okay too. What about this one? How would you think about the third root of y to the 4th? Well, that's like this in reverse. I'm given something that looks like this, and I'm turn it around and think about it like that. So third root of y to the 4th power would be the same thing as y to the 4/3 power. Okay. What about 27 to the negative 2/3 power? Well, so we learned about negative exponents. So to handle that part of it, I would do 1 over 27 to the 2/3 power. Okay, but then that fractional exponent is thought of like this. So this would be the third root of 27 squared. Okay, and the third root of 27 says what number, if I raise it to the third power, will give me 27. That's how you determine that. Now, I say it again, I know you could use a calculator to do that or anything else, but I want you to know what this means. Third root of 27, what number do I raise to the third power to get 27? That'd be 3. 3 to the third power is in fact 27. So that's that part of it, and then I gotta square it. 3 squared is 9. I get 1 over 9, so 27 to the negative 2/3 power is 1 over 9. Okay, so let's take one more. What if you had n to the 2/5 power? Well, here we're doing algebra again. Like, you know, 27 is a number, and I can do calculations all the way with it. But n, it might be a number, but I don't know what it is. It's not given. I just have to do whatever I can with it. So for that, I guess we could say either one of these could be the answer. We could say the 5th root of n squared, or the 5th root of n squared like this. All right, either one of those would be correct and proper, and you might see either one of them along the way. Real quick, let's say, what about 0? Sometimes we see 0 as an exponent. If I take a number and raise to the 0 power, you will get 1. There's an exception to that. 0 to the 0 power is undefined, meaning it's an impossible calculation. It doesn't have an answer. Okay, so all right, if you take a number to the 0 power and you get 1, then 4 to the 0 power would be 1. Okay, if we have a 0 exponent in the mix with something else, 5 divided by 6 to the 0 power, we'll just do that one step at a time. 6 to the 0 power is 1, 5 divided by 1 is 5. All right, so in case you see the 0 exponent, it might be nice to just know what it means. Let's do this. One more thing. Again, with our class being academic, college level class, I want you to know as much as you can. All right. So I thought I could give you a chance to think about the reason for that. In math, like there's almost always a reason for everything. Okay. So why is n to the 0 power 1? Why is it that when you raise a number to the 0 power you get 1? Well, let's think about this example. N to the 4th power over n to the 4th power. This will give me a chance to show you why this is true. So one way to do this is by a rule for exponents. We have a rule for exponents, which I might write this way: n to the power a over n to the power b. Here we're dividing like things, n and n. And there's a rule for exponents that says when you divide like things, then you subtract the exponents. Okay, so n to the 4th power divided by n to the 4th power, if this rule is used, would be n to the power 4 minus 4, but that's 0. So if you did it that way, you would get n to the power 0. Is there another way to think about this? Well, when you divide anything by itself, except 0 divided by 0, you get 1. Okay? So another perfectly good way of thinking about this is that you get 1. So then from there we can make the connection that, well, if I do it this way, I get n to the 0 power. If I do it this other way, which is still perfectly correct, I get 1. So it must be that n to the 0 power is 1. Okay, so we can reason along those lines to get an expression of this rule in general. Okay? All right, so that's everything. That's a crash course on exponents. I could say keep going on, give more examples, say way more about this, but I think that this is enough just as kind of a bare minimum to get you acquainted with the way you might see exponents in the upcoming lessons.